Hi friends, today we will be solving the problem that is problem of the day. Remove all the occurrences of a substring. So basically we have been given a string s and a substring part. We need to repeatedly remove part from s until it no longer appears in s. So our goal is to return the final modified string. So basically we have been given this string and we have to perform the following operation on s until all the occurrences of the substring part are removed, and also finding the leftmost occurrence of the substring part and remove it from s. So we have to return s after removing all occurrences of the part. So the brute force approach that we can think of is basically we can repeatedly find and remove the substring part from S. So basically approach will be like finding the first occurrence of part in S using the s.find method, and then removing that occurrence using erase function. Then we have to repeat this process until s.find part returns -1. That means part no longer exists in S. So we can also dry run this. So basically 0. These are the indexes, and we have this S is string. So in this string, the part we have been given as ABC. So we have to find ABC in this. So we can see clearly like it is ABC at index 2. So basically at this point we got ABC. So we will remove ABC and S will become this. Then again we will do the same process. We will find ABC at index 4. Again we get at index 4, that is here, this ABC, and we will remove ABC. Then again the string will be modified. Again we will check for ABC, and this time we get at index 3. So we will again remove ABC and S will become DAB. So the finally, after removing all the parts, we are left with DAB. This is the final answer. So the problem with the brute force approach is basically the find function will take O of n in worst case time complexity while scanning through S, and the erase function will take also O of n time complexity for shifting characters in S. So the loop will runs for O of n or m times, where m is the part length, and again the total complexity will become O of n square in worst case when erase function is repeatedly shifting characters, and space complexity will remain same and it will be constant as we are not taking any extra we are not using any extra space. So let's go towards the better, or we can say the optimized approach we can think of right now is basically using stack. So what we can do is basically we can dynamically construct the result string which will directly acting like a stack. So each time we append a character, we will check if the last part dot length characters matches the part. If they do, we will remove them efficiently. So basically how it is different from brute force. So basically instead of repeatedly searching and erasing, we use a growing string which is acting like a stack. So we will append characters one by one. Whenever the last few characters matches part, we will remove them in O of 1 time compared to O of n in brute force solution. So basically at the end we will return the final string which already exists, which already contains all the valid characters also. So basically we will start with an empty string. We will initiate it with result variable. So in the second step we will traverse S and appending each character to a result. Then again, if the last part dot length characters in the result matches the part, we will remove them instantly. And at the end, result contains the final modified array. So the time complexity in this solution will be O of n, because each character is pushed and popped at most once. Getting my point? Like we are pushing and popping it only once. So basically time complexity will be O of n, and the space complexity will also be O of n, since we store the result in a separate string. So let's dry run this approach. Basically we can see we have a input array as same as in brute force solution. Input string as same as brute force, and the part is abc. So we have taken this processing, we will process each character step by step. So in the first step we have d, so we will push d into a stack and we will append d. In the second step we will have a, so we will push again in the stack and we will again append a. In the third step we will again push it. We will in the fourth step b will be getting pushed in stack, and in the fifth step we will mm, we will see, after pushing c we are getting abc, that is a part. So we will match abc and we will remove it because it is a part. So we will remove it. Then after this step we have b, we will straight away push into a stack and it will become dab. So in the next step we have again a, so we will push it again into the stack, and again we have a, so we will again push it or append it, basically what we can say. And again we have b in it, so we will push it. Next time we have c, so the string becomes abc. So again we are getting abc, so that is matching with the part, so we will remove it. So again we are left with dab after pushing b. Again after this step we have c, so the string will become dabc. So abc after pushing c, it will become dabc. In the next time at last, as we can see, we found abc, we will remove it, we are left with da. After that b will get pushed, the final string will be dab. So this is the required output of our given string. So basically we can say that brute force repeatedly searches and erases, leading to O of n square complexity, time complexity. But optimized approach, which we are using, stack init, builds the result string once and removes the substrings in O of one time, that is push and pop operations, and giving O of n complexity. So basically we can say this. We can see it through code itself, like how we are doing it in a compiler. Let's show you on LeetCode itself how I have solved it. Basically, after, let's go through the code. Yeah, so this is our remove occurrence function. We are passing a string and a part which is given in the question. We are constructing a result string which is empty right now, which will act as a stack to build the final result. Then we will traverse our string, that is traversing each character in the string, and we will append the character to the result, that is pushed back. Here we are pushing it back. So basically we also do the check condition if the last part dot length characters form the part, like we saw in the dry run. We were as soon as we get the abc, they are matching with the part, so we are removing it. So here we have that condition only. So this is the condition, and it will remove the part from the result string. After doing this, we will straight away return the result. This will return us the final modified string. Hope you all get the solution. Thank you. If you like the video, please like and drop a comment if you understood the solution. Please like, share and subscribe.